In Chapter 14, Exercise 18, they're giving you the name of an amide, and they're asking you to draw the structure. So here, let's start with the backbone. The prefix is hex, and so we know we're going to have 6 carbons. So here's 1, 2, 3. Actually, let me start this way. 1, 2, 3, 4, 5, 6. Let me just make sure. 1, 2, 3, 4, 5, 6. Okay, so that's our hex. Now, inside of that, we have the infix AN. That means that we're going to have all single bonds between those carbons. Good there. And last but not least, the suffix is amide, and that means that we have an amide on the end of this chain. It's a carbon double bonded to oxygen, single bonded to a nitrogen, or to an amine. Nitrogen needs 3 bonds, and so you would just draw in those other 2 hydrogens, and this is the structure for hexanamide. Let's try 3-chlorobenzamide. This one's a little strange because benzamide is actually a common name. This is a benzene derivative. A benzene derivative, remember, benzene is a 6-membered ring with alternating single and double bonds, and here coming off of it you would have an amide. So here, carbon double bonded to oxygen, single bonded to nitrogen. The nitrogen needs 3 bonds. So that is benzamide, and there's no way you could really know that unless you had been exposed to it or had memorized it. Benzamide. Now, you always number these benzene derivatives at the carbon on the ring where the functional group is coming off, so that's right here. Since we're creating the molecule, we can number it however we want. I'm going to go around clockwise. It's on carbon number 3 that we have this branch. And so we have this branch coming off of carbon number 3, and it's a chloro. That means it's chlorine. So this would be the structure for 3-chlorobenzamide. Kind of an unusual example. Here we have 3-methylbutanamide. This is more of a normal one. Now, let's draw the backbone first. We know that everything before a YL is a branch. So after the YL is butanamide, that's our backbone. But is telling us we're dealing with 4 carbons. So let's say, okay, 1, 2, 3, 4. And actually, let me do that over again. Here we have 1, 2, 3, 4. Okay, just to be sure. 1, 2, 3, 4. The infix is AN, so that means we have all single bonds between those carbons, and you can see that here. And last but not least, the suffix is amide. And an amide means that you have, on the end there, carbon double bonded to oxygen, single bonded to a nitrogen. Now, because we don't have any branches that start with N, we know that coming off of the nitrogen is just going to be 2 hydrogens. Remember, nitrogen needs 3 bonds. The branch that we're given is said to come off of carbon number 3. So it's going to be coming off of this carbon right here. What type of a branch is it? Well, the prefix is meth, and so we know that we're going to have just 1 carbon in the branch. Other than that, we know it's a branch because it ends in YL. So we have that 1 carbon branch coming off of carbon number 3, and that is 3-methylbutanamide. Last but not least, let's draw the backbone first. We know that because this ends in YL, that's a branch, and so the backbone is propanamide. Propanamide. The prefix is prop, so we're dealing with 3 carbons. So we've got 1, 2, 3. Just to make sure, 1, 2, 3. All right. In between those carbons are all single bonds, and so the infix is AN. That's represented by the AN. And the suffix is amide, which is telling us we have an amide. You put the amide on the end. An amide is a carbon double bonded to oxygen, single bonded to nitrogen. Notice I'm not adding any more carbons. That would have changed the prefix. I'm just adding the oxygen and nitrogen to one of the carbons on the end. Now, that is our backbone. We just have one other branch, and we can see that the branch is coming off of N-ethyl. Oops, N-ethyl, that's our branch. That N there is telling us that the branch is coming off of the nitrogen. So where this branch is going to be attached to the nitrogen. The prefix is F, and so the branch is going to have 2 carbons, so 1, 2, coming off of the nitrogen, 1, 2, and other than that, it's a branch because it ends in YL. So we know nitrogen needs 3 bonds. It's only 2 are drawn, so we draw another hydrogen in, and otherwise that is N-ethyl propanamide.